So 4.3, the scientists studied 1,500 more births and recorded the mass at birth of each baby and the nature of the KIR gene in the mother's genome. We are given the results, and the scientists used a statistical test to test the following null hypothesis. So they are saying that as it is a null hypothesis, then the presence of this KIR2DS1 in the mother's genome does not affect the frequency of births above 4,500, and they would like to know the name of the statistical tests that the scientists would carry out in order to test this hypothesis, and they would use the chi-squared test. The reason why it would be the chi-squared test is because this is the test that they would carry out when they are trying to identify to see if there is a significant difference between the values that are obtained and those values that are expected. A correlation coefficient is trying to find out if there is a relationship or a correlation between two different variables, and a t-test is carried out when you have two means that you are trying to compare. So our answer must be the chi-squared test. So part of 4.4 tells us that the scientists calculated a p-value of 0.03 when testing their null hypothesis. What can you conclude from this result? So the magic number that we are looking for in science is a probability of 0.05, or the idea of a 5% probability. So as our number is lower than that, then we would look at the probability that the difference is due to chance is less than 0.05 or less than 5%, or we could state that the probability that the difference is due to chance is 0.03. Okay, therefore we would reject our null hypothesis because we are saying that the difference is therefore going to be a significant difference. We mustn't just say that the results, it must be that the difference has a probability that is less than 0.05, or the idea that it is 0.03, which is less than the 0.05. Therefore, we're rejecting our null hypothesis because the presence of this allele does affect the frequency of a high birth mass. They are ignoring just the idea that the results are due to chance. They are accepting that the probability that difference in frequency is not due to chance is greater than 0.95. And they are also accepting an abbreviation for the null hypothesis. If you don't state rejecting the null hypothesis, they will also accept do not accept, but they will not allow disprove or wrong.